Hello, Legacy Savers. Today we're going to be talking about the average rate of change, and what you're going to need for this is your notebook, a pencil, and a foldable that you're going to be taking notes in. The learning target for this video is I can describe a rate of change given a table, a graph, or a context or a situation. Okay, let's think back to Algebra 1, and this is an introduction into rate of change. So we're given a situation. In 2008, about 6 million US households had both landline phones and cell phones, and we need to describe the change in the table. So we've been given a table. In our left-hand column, we have the year 2008, 2009, 2010, and then in the right-hand column, we have households by the millions. So how many households have had so many landlines and cell phones? Okay, so remember in Algebra 1 when we talked about describing the change, we went from one row to the next and we said this added 1 because we went from 2008 to 2009. And then when we did from 2009 to 2010, it still increased by 1. And in 2010 to 2011, it increased by 1. Now let's find the pattern in the right-hand column. 66 to 61, we decreased by 5. 61 to 56, we decreased by 5. And then 56 to 51, we decreased by 5. So rate of change, we're going to talk about steps to calculate rate of change, and then we're going to revisit this table and this scenario and talk about what we want to interpret from the situation using the rate of change. Okay, so the rate of change can be determined from graphs, tables, and even equations themselves. The rate of change is found by this fraction, delta y over delta x. And this little triangle delta, we read that as change in y over or divided by the change in x. So if you want to say change in y, that's how we read delta, or if you want to say delta, change in x. So we calculate the rate of change by the change in y over the change in x. So we have 5 simple steps when we're talking about calculating rate of change. The first step would be identifying the starting point of the interval, and for the interval we're looking for the starting point for both x and y. And that would be the same for our second step, identifying the ending point of the interval for both x and y. And then the third step would actually be calculating my rate of change. We need to find the change in y's on my interval and the change in x's on my interval from the starting and ending points. The fourth is your result, or simplifying that fraction that you get in step 3. You're going to get a fraction as an answer, so we want that in simplest fraction form. And understanding that that is an average rate of change for the interval between the 2 points that we have. And then our last step is interpreting our answer in the context of the problem, which is arguably the most important step of all these steps to calculate rate of change. What does it mean? What does this rate of change mean to us within the context of the problem? That's the final step, number 5. Okay, let's revisit that situation with this table where we want to describe the rate of change between the years 2008 and 2011 for the cell phones and landlines with households that had them in millions, right? So we need to first identify the starting point, and my starting point is in 2008 with 66 million households having landlines and cell phones, right? And then my ending point would be in 2011 when 51 million households had cell phones and landlines. And now my third step is calculating that change in y over change in x. The change in y and the change in x are just subtracting or finding the difference between the starting and ending point. So you can do start minus end or end minus start, okay? I usually do start minus end, so top minus bottom. So remember, our y column is the households in millions of dollars, so we want to do start minus end, which is 66 minus 51 million, all over the change in x. So our starting point is 2008 minus the year 2011. So 66 minus 51 is 15, and 2008 minus 2011 would be a -3. And now we have to simplify this fraction. 15 divided by -3 is -5. So my answer is a -5, but we need to interpret that average rate of change for my interval between the starting and ending point. We need to interpret our answer in the context of the problem. What this -5 means is that, I'm going to draw a line here so I can write my answer. On average, each year from 2008 to 2011, about 5 million households have gotten rid of, because that negative sign is telling me that it's decreasing, right? Have gotten rid of landline and cell phones. And we know that it's decreasing also because if we look in our right-hand column, we're going down in numbers 66 to 61. So we're decreasing. So we're on average from 2008 to 2011 each year, 5 million households have gotten rid of landline and cell phones. That is what this -5 average rate of change is telling me, okay? So we have 2 more examples to go through in this foldable. Okay, let's look at example number 1. The table below represents a type of bacteria that doubles every 36 hours. A petri dish starts out with 12 of these bacteria. Our goal is to calculate and interpret the average rate of change from x is equal to 2 to x is equal to 5. So remember our 5 steps. We first want to identify the starting point for our interval, and that would be at x is equal to 2 and y is equal to 30. That's my starting point. And now we want to identify the ending point, which is at x is equal to 5 when y is equal to 121. And now we need to calculate my average rate of change. So the change in y over the change in x. And my change in y would be 30 minus 121. I take start minus end over my x values are 2 minus 5. 30 minus 121 is a -91 over 2 minus 5 is a -3. So now we need to reduce this fraction. Unfortunately, 91 over 3 cannot be reduced, but I do know that these negative signs can cancel. So my final average rate of change is 91 over 3. But now we have to interpret that rate of change. And our interpretation is, on average, the bacteria is increasing by 91 every single 3 days. So if you've noticed, our interpretation is saying first, on average, then we talk about the change in y. The bacteria is increasing this time. On our last example, it was decreasing. We say by how much, and then we have to say every 3 days, which is our change in x. So that's how we come up with those interpretations. And they should look pretty similar to how we set them up each time. Okay, example number 2. We're going to solve 2 problems looking at this graph, and so let's look at the first one. We want to find the average rate of change for the intervals from x is equal to 1 to x is equal to 3. So first I have to look at my graph and find the ordered pairs at x is equal to 1 and x is equal to 3. So I have to follow my graph as at x is equal to 1, which is that dot right there. So I think that that point is about 1,550. Which means that my x value is 1 and my y value would be about 550. I'm just guessing. And then for x is equal to 3, that's our point, our second point, which is a little bit higher. And I'm guessing that the y value on that ordered pair is 1,150. So now we have to calculate, we found our starting and ending points. Those are our first 2 steps. Now we have to calculate the change in y over the change in x. So my change in y would be 550 minus 1,150 all over the change in x, which would be 1 minus 3. So 550 minus 1,150 is a -600 all over 1 minus 3 is a -2. Can we simplify 600 over 2? Yes, we can. Well, we know the negatives cancel, and 600 divided by 2 is equal to 300, which is my average rate of change between those 2 points on this graph. If we were to interpret that, we would say on average, investments in dollars increase about $300 every day. I think, nope, sorry, every year. Reading my labels wrong. Okay, so now the next one we need to ask is from x is equal to 3, which is this point on the graph still, to x is equal to 6. And x is equal to 6 kind of goes off the graph a little bit, so I'm going to guess it'd be a point like right up here. And I'm going to guess that our point up there would be 6,3250, but that's just my guess. And now we have to find the change in y over the change in x. We identified our starting point and our ending point for this number 2. So the change in y would be 1,150 minus 3,250 all over my change in x, which is 3 minus 6. So 1,150 minus 3,250 would be negative 2,100 all over 3 minus 6 is a negative 3. We know that the negatives will cancel. 2,100 divided by 3 is equal to 700. So if I were to interpret this average rate of change, I would say on average, investments in dollars increase about $700 every single year. So the last question that they want us to ask is which interval has a larger average rate of change? Well, 700 is greater than 300, so our answer here would be from x is equal to 3 to x is equal to 6. I want to thank you all for taking such good notes, and I will see you soon.